So now it's time to run the actual regression. So we come up to Analyze, go to Regression again, Binary Logistic. We've already got this variable, our outcome variable, in the dependent list from the assumption check that we had. But okay, let's move these two variables out, the two logged variables. Keep OGS and PRSN, our original variables, and then go ahead and add the categorical variables as well. And as I said, we want a Caucasian to be the comparison variable for our race dummy variables, so we just put in African American and Hispanic. Your book goes over another way where it kind of automatically picks the categories, but just to be safe, I always go and just code out the dummies myself, so just be aware of that. So if you do it my way, you don't have to really click on the categorical section here. Come down to options, make sure these are checked. I don't actually go over all these, but get in the habit of checking these because it gives you some useful information. Click continue. Once again, just like multiple regression, you can enter this into multiple ways. You can have the forced entry method, and again, if you go about and you do this next, it would enter stuff in blocks, which is what your first example in the book does. And what's useful about that is that you can compare the usefulness of the models, and does your usefulness of the model increase as you add new variables. But you can kind of read about it in the book, and it's kind of the same concept of what I talked about in the multiple regression unit. So we're just going to do all at the same time, which is how I recommend to do this, unless you have a specific reason to enter variables in steps, which would normally be if you're conducting some type of really new research. But for our purposes, we're just going to put it all in at the same time. So come down and click OK, and our variables start here at logistic regression. But there's a lot of stuff that it's probably, depending on how detailed you want to get into things, can be important, but we're only going to look at a couple things here. First thing I want to say, block 0, you don't need to really worry about what's in block 0. We can skip down to block 1, which is all the stuff actually entered into the regression, all of our predictor variables entered into it. Now, I think basically all the stuff that I want you guys to know in this class we can interpret in 3 steps. First thing we want to do is check the model. How useful is the model? The second thing we want to do, step 2, is interpret what we can call our pseudo R-squares. They're essentially very similar to the R-squares we had in multiple regression, but not entirely the same. And then step 3, we actually interpret our predictor variables and the results from that, and that's what's usually most important in many cases if you're doing any hypothesis testing, because that's where you'll get those results. So okay, but step 1, as I said, is to check the actual model, and this is very similar to how we check that F test in the multiple regression, but in logistic regression, the results that we want are in this omnibus test of the model coefficient, which is actually a chi-square test, but it achieves the same, basically the same purpose as that F test in multiple regression. You want to come down and check this model, and then check what we're really concerned with here is this model significant? And if it is, we back up, significant again being below 0.05 or below. And again, if this is significant, it's essentially telling us we have a useful model. And what that means with logistic regression is that by including the predictors that we did in our model, in our logistic regression equation, we are better able to predict the outcome of the outcome variable, whether someone falls into category 1 or category 2 of the outcome variable. And so essentially it just tells us, are we improving our ability to predict that as we add these variables, these predictor variables, into our model compared to when we don't have those in account. And long story short, if this is significant, you can say that you have a useful model. So that's step 1. Step 2 is to interpret our pseudo R-squares. And there's a lot of these out there, but SPSS gives us 2, the Cox and Snell R-square and the Nagelkerke R-square, and these are both in the model summary table. Now the way these are calculated is a little different for each test, and they're not the same way as you would for an actual R-square, but they're often interpreted somewhat similar to an R-square. I recommend using the Cox and Snell because it's a more conservative estimate, so that's what I'm going to use in my example here. But just like with an R-square, you can convert this to a percentage by timesing it by 100, so this would give us 18.3%. And what does that tell us? That tells us that when our predictor variables are included in the model, we have a proportionate reduction in error of 18.3%. Okay, so what does that mean? Well, that essentially means that we have less errors in our predicting what category the outcome variable, essentially a person or something, will fall into, reduces as we put these more variables in. As we add more predictor variables, that error in prediction of the outcome variable is reduced. And so just like with R-square, a higher value here essentially still represents that you have a better model and that your predictor variables are better at predicting the outcome. So that's step 2. Step 3, which is the meat and potatoes of this one, is to determine what predictors are significant and then interpret the results of those significant predictors. So for that, we want to come down to our variables in the equation table. Now, one thing I would like to stress here is you guys made this mistake in a few of the other types of regression. The constant, we don't interpret the results for that. We just want to look at the variables that we entered into the model. And the first thing we want to do is come over and see which of our variables were significant. In this case, OGS and PRS, offense gravity score and pry record score, are both significant, but none of the other variables were significant. So if we were actually doing this test, then we would report the results for our significant variables, but would probably just say that the other variables were not significant, which can be important. And the hypothesis I gave you guys in the written part of this lecture, that's kind of important to these results. But let me kind of break down how to interpret this. Long story short, you want to look at significance first, as I said, and then for interpretation, you could use the B over here, as I talk about in my written notes for this interpretation. That's kind of complicated, and a lot of lay people that don't know a lot about statistics or haven't been introduced to this before probably won't be able to understand that interpretation. So what I like to use is the exponent B, and this tells you the change in the odds of a specific outcome occurring, which means the odds of essentially people in your sample falling into the one category of whatever your predictor variable or whatever your outcome variable is. So it tells you the change in the odds of that outcome occurring for each 1 unit increase in the predictor variable when you have continuous predictor variables, and such as OGS and PRS. And an even better way to do that, you can actually change this into a percentage by taking this exponent B value, so in this case 1.428, subtracting 1 from that, and timesing it by 100. And that essentially gives you a percentage. With that, you can determine the percentage change in the odds of an event occurring for each 1 unit change in that continuous predictor. So to actually change this for our OGS score, our offense gravity score, okay, this is 1.428, so you subtract 1 from that and times it by 100, we get 14.3. And so we would interpret this as followed, and using the actual variables we had, the odds of a judge diverging from the sentencing guidelines increases by 14.3% for each 1 unit increase in OGS scores. So again, it tells us the percent change in the odds of an event occurring. In this case, that event is what was coded as 1 for our dichotomous outcome variable. In this case, that was a judge diverging from those sentencing guidelines and sentencing, essentially not using the guidelines as part of their sentence. So again, we could say For this sample, the odds of a judge diverging from the sentencing guidelines increased by 14.3% for each 1 unit increase in OGS scores.